Hello everyone, my name is Saksham Purbe, and this is my presentation for Lab 2. The overall purpose of this lab was to generate a computational model to study the interactions between two charge tapes and approximate the excess charge. The fundamental concepts involved in this experiment are as follows. We use Newton's second law, which states that force is directly proportional to mass times acceleration. We use a separate formula for calculating the electric field by treating the tape as a rod. We had the formula for the electric force, which states that the force is equal to the charge times the overall net electric field. And Coulomb's law, which allows us to quantify electric force, which by multiplying 9 times 10 to the 9 times the two point charges over distance squared times r hat. We described our setup in a way where the system was described as the suspended U-tape and the surroundings as everything else, including the base tape. We assumed that the charge was evenly distributed and that both tapes would have the same amount of charge, and we also assumed that air resistance could be ignored. The main results from Lab 1 are summarized here. We observed that both tapes exhibited a positive charge, and due to their likeness in charge, they repelled each other. The charge on the tape was quantified and calculated to be 9.6 times 10 to the negative 9 coulombs, and we approximated that the tape would lose about 6 times 10 to the 10 electrons, and that the tape contains about 4.017 times 10 to the 6 atoms for every electron. In Lab 2, we altered our approach and used a line charge method for calculating the charge on the tape. By equating the electric force to the gravitational force, we were able to derive a analytical way of calculating Q. And after following those calculations, we derived the charge of the tape to be 1.98 times 10 to the negative 8 coulombs. And after doing our calculations, we found that the charge calculated in Lab 1 was about 48% of the charge we calculated just now. Here is the code for our experiment. We used this overall section to calculate the electric field of the tape while treating it like a point charge, which allows us to then calculate the electric force. We used this particular section to calculate to model the line charge. And then the section on the left was used to model the law of superposition that allowed us to model the electric fields at various locations. When modeled as a point charge, the electric field can barely be seen, as indicated by the white. And the yellow, which represents the gravitational force, completely dominates. The green here represents the electric fields at various points of the tape. After using the new approach and calculating a Q to be 1.98 times 10 to the negative 8, we inputted that into the model and ran our code again. As seen here, the overall output looks to be more accurate, where the electric force and gravitational force are somewhat equivalent. This experiment saw a lot of handling of tapes, which could have led to a lot of errors. So the potential source of error in this experiment could have been the measurements taken about the tape, including the tape measurement and the separation distance, along with the loss of charge during setup. What if we had modeled each of our tapes as a single point charge? When comparing the two ways of modeling, we can see that the point charge model led us to get 9.6 times 10 to the negative 9 coulombs, and the experimental way got us to get 1.98 times 10 to the negative 8 coulombs, where the experimental way was a scale of 10 larger than the point charge method. These estimates differ due to their differences in the approach and the general formula. Overall, we believe that the approach used in Lab 2 would be closer to the real value, since it deploys infinitesimal steps to superpose and yield the overall net charge in our calculations. Thank you so much.